All right, so we'll go ahead and get started with problem number 1. And that is to solve the given equation for x, which is 6 to the 2x minus x squared equal to 6 to the negative 8. And this is one of those exponential equations here that we have. 6 to the 2x minus x squared equal to 6 to the negative 8. And in this case here, we got the bases that are exactly the same, as you can see. So that means here, with these exponential equations, when the bases are the same, we can set this exponent to be equal to that exponent. So I can set 2x minus x squared is equal to negative 8. And then we go ahead and solve this quadratic equation because the highest exponent is x squared. So here, I'm going to move the minus x squared over to where that minus 8 is by adding x squared to both sides. And also I got this 2x. I can move that over as well by subtracting 2x on both sides. So here I have a 0 on the left side, and then on the right side, I'll have x squared minus 2x minus 8. And here I can factor x squared minus 2x minus 8 into two binomials here. So I'm going to break x squared up as x and x. And then for factors of minus 8, that would give me a minus 2x as a middle term will have to be a minus 4 and a plus 2. Because minus 4x and a plus 2x will give me the minus 2x as a middle term. So I got x minus 4 times x plus 2 is equal to 0. And then we can set each binomial factor equal to 0. So I have x minus 4 is equal to 0, or x plus 2 equal to 0. And then for each equation, I'll solve for x. So for that x minus 4 is equal to 0, that will mean x has to be equal to 4. Or for the x plus 2 is equal to 0, it'll be negative 2. So my two solutions will be x equals 4 or x is equal to negative 2. Are there any questions about problem number 1?
No.
Okay. All right, number 2 says find the value of the investment of $20,000 for 11 years at an annual interest rate of 3.85% compounded continuously. So we have a $20,000 investment, that's what P is, for 11 years, that's time, T, 11 years. Interest rate, annual rate of 3.85%. Now, 3.85% as a decimal, you have to think of this. Take that 3.85 and divide that by 100, because percent means per 100. It'll be 0.0385.
You divided R by 100?
Yes.
Okay.
Now it says compounded continuously, so that means we must use this formula. A is equal to P times e to the RT. So that means A is equal to, we substitute the P with 20,000 times e to the R, that's going to be 0.0385 times T, which is 11. Now this we can type into our calculator. So I can type in 20,000. Now for the E, in this case, you have to press your second key and LN, because right above the LN key is your E. And then you'll do 385 times 11. Then hit enter. Now we're dealing with money amounts, so we always round to 2 decimal places. So this will be $30,545.96. So the amount, the value of the investment of $20,000 for 11 years at 3.85% compounded continuously would be $30,545.96. Okay. Are there any questions about problem number 2?
Mm-mm.
Okay. Now number 3. Suppose that $5,700 is invested at 3.5% annual interest rate and is compounded monthly. How much money will be in the account for 19 years? Okay, so our principal is $5,700. Interest rate is 3.5%. And 3.5% as a decimal would be 0.035. So take that and divide that by 100. That'd be 0.035. And it says here, if it's compounded monthly, we need to know how many months are there in a year. That will be 12. And this will be for 19 years. So T is going to be 19. Now here we're dealing with n number of compoundings in a year. So that means we need to use this other formula. And that's this. A is equal to P times the quantity 1 plus R divided by M. And that's to the M times T. Because we're dealing with M number of compoundings. And then we do our substitution. So here, the P is $5,700. And then 1 plus R, that's going to be 0.035 divided by M, which is 12. All that's going to be raised to the M, which is 12 times T, which is 19. And then we can type all this in the calculator by typing in 5,700. And then left parentheses, 1 plus R, that's going to be 0.035 divided by 12, close parentheses. And then press the hat key for your exponent. It'll be 12 times 19. And then hit enter. So the 2 decimal places, this will be approximately $11,072.87. Okay, so that will be the amount of a $5,700 investment at 3.5% compounded monthly after 19 years. Questions on problem number 3?
No.
Okay. Problem number 4 is solving for x in the equation. Here we got log to the base b of x plus log to the base b of x minus 3 is equal to the log to the base b of 40. All right, now in this case here, with these logarithmic equations, we need to condense the left side as a single logarithm. Here we got the sum of the individual logarithms, which can be condensed as the log of the product. We have to use the product rule. Sum of the individual logarithms condenses as the log of the product. So in this case, we have log to the base b of x times x minus 3. And then that's equal to log to the base b of 40. The right side is a single logarithm. And then we're going to use something called the one-to-one property. That means I got log to the base b on both sides of this equation. I can set this expression to be equal to that expression here. I can take that x times the quantity x minus 3, set that to be equal to 40. And from here, we can just simplify this by distributing the x over the x minus 3. Here, x times x, that's x squared, minus x times the 3 will be 3x is equal to 40. Now, since I have a quadratic equation, I need to get a 0 on one side of this equation. So I need to move the 40 over to where x squared minus 3x is by subtracting 40 on both sides. So that means I have x squared minus 3x minus 40 equal to 0. And on the left side, I'll go ahead and factor into two binomials. So that x squared breaks up as x and x. And then factors of negative 40 that would give me a minus 3x will have to be, let's see here, I'm going to try negative 8 and a plus 5. Because minus 8x and a plus 5x will give me the minus 3x that I need. So it'd be x minus 8 times x plus 5 is equal to 0. Now we set each binomial factor equal to 0. So that means x minus 8 is equal to 0 or x plus 5 equal to 0. Each equation we solve for x. So for the x minus 8 equal to 0, that means x is equal to 8. And then for the x plus 5 is equal to 0, that means x is equal to negative 5. Now, one of these is the exact solution to this equation. And the one you can eliminate is this x equal negative 5, because if I replace the x with negative 5, I'm going to have a log of a negative here and also a log of a negative here. I cannot take the log of a negative number. So x equal negative 5 has to go. That would mean x equals 8 is the solution to that logarithmic equation.
You said it wasn't 5 because it wouldn't equal 0 if you plugged it in.
Well, if you replace the x with a
yeah.
negative 5, you're going to get a log of a negative number, which we cannot take.
So on the test, we should plug it into the...
Yeah, you can, if you have the time. Because you want to check, basically, you want to check your proposed solutions on these logarithmic equations. All right, any other questions? Okay, number 5 is another logarithmic equation. Here we got log to the base 10 of x minus 7 minus log to the base 10. X plus 7 here. The other one's log to the base 10 of x minus 7 is equal to 1. Let's see if we can condense the left side as a single logarithm. Now that left side, you got the difference of the individual logarithms, so we need to condense that using what they call the quotient rule. the quotient rule. That means I can write this as log to the base 10 of here x plus 7 is in the numerator, and then x minus 7 will be in your denominator, and that's equal to 1. Notice I have a logarithm on one side of this equation, which means I need to write this in its equivalent exponential form. What I mean by that is this. That base here, which is subscript for your log, is your 10. That's going to be the exponent for this 1. So the 1 will be your exponent for 10, so it'll be 10 to the first power. That's going to be equal to that expression right here. So log to the base 10 of x plus 7 divided by x minus 7 equaling to 1 in its equivalent exponential form will be 10 to the first power equals x plus 7 divided by x minus 7. And 10 to the first power will just be 10. Now, since I have a fraction here on the right side, I'm going to write that as 10 over 1, equaling to x plus 7 divided by x minus 7. And then do cross multiplication here. Multiply this 10 times that x minus 7. And then that's equal to this 1 multiplied by x plus 7. Here I'm doing just cross multiplication. Probably be easier to do it that way. Now, distribute the 10 over the x plus x minus 7 will be 10x minus 70. And distribute the 1 over the x plus 7, that's just simply going to be x plus 7. So I got 10x minus 70 is equal to x plus 7. Then the next step would be to get all the variables on one side and the numerical terms on the other side. So let's move that x over to where 10x is by subtracting x on both sides. So 10x minus a 1x, that's 9x, minus 70 equals 7. And then to get the 9x by itself, we add 70 to both sides. So 9x is equal to 77. Divide both sides by 9. That will mean x is equal to, and I will leave this as 77 over 9. And I'm not going to get a negative when I replace the x with 77 over 9. So I can say x equals 77 over 9 is the solution to that logarithmic equation. Okay. Questions on problem number 5. All right, number 6 is solve the equation of 4 decimal places. Here we got e to the power of x is equal to 2.405. And to solve that exponential equation with the natural base e, there is a property that says that ln and e are inverses of each other. So to solve this, you're going to have to take the natural log on both sides, or the ln on both sides of this equation. So ln of e to whatever my exponent is that exponent. So ln of e to the x would just be x, and then that's equal to ln of 2.405. And we're going to round to 4 decimal places using our calculator. So we press the ln key, and then type in 2.405, close parentheses, and then hit enter. Let's see, the 4th digit after the decimal point is a 5. To the right of that is 4. 4 is less than 5, so we leave this 5 as is. So it'll be approximately 0.8775. So that would be the approximate value of x for number 6. Okay.
Do we always use the,
Yeah, you can.
okay.
All right, any other questions? Okay, number 7 is another exponential equation. And in number 7, we got 1.373 raised to the 12t is equal to 2. Now, again, this is an exponential equation, and the only way you're going to be able to solve this exponential equation, since we got the exponent here, is to take the natural logarithm on both sides of this equation. Now, on the left side, there is a rule that says if you have ln of some constant raised to a power, I can take that power and pull it in front of the natural logarithm. So that 12t will go in front of the natural log of 1.373. And then that's equal to ln of 2. Now, the way we're going to get t by itself is to divide both sides by the 12, and, of course, the natural log of 1.373. Now, when we do this in the calculator, the whole thing, the denominator needs to be in parentheses. So here, t will be by itself. But when we type this in, we got ln and then 2, close the parentheses, that's the numerator, divided by, now for the denominator, I need to use left parentheses. And then 12, and then let's say left parentheses, ln 1.373, close the parentheses around the 1.373, then I'm going to close the parentheses again and again. I hope this is right. Yeah. It'd be 1.8. And if we do this to 4 decimal places, 1.822. Point 1822. Okay. Okay. I think we can do it by just saying 12, then ln, and then 1.373, close parentheses, and then again, same thing. Yeah. So really, I don't need the parentheses before that natural log. Okay. Are there any questions? Okay, number 8 deals with, well, from here on out, this deals with just limits. All right, so problem number 8. Here you're going to use the graph of the function to estimate the indicated limits and the function value. So in part A of number 8, you have the limit as x approaches -1, and that's from the left, of the function f of x. So here's 1 right here. As we approach 1 from the left side, where's -1? Here's -1 right here, I'm sorry. -1. As we come from the left of -1, f of x value is going to get closer and closer to the y value, which is, in this case, is on the y-axis, the x-axis, which is,
-1.
no,
That
0, the y value. So the limit as x approaches 1 from the left of -1 is 0. That's part A. Part B, the limit as x approaches -1 from the right of f of x, and it should say -1, yeah. So as we come from the right of -1, we're getting closer and closer to what y value?
0.
Again, 0. Okay. All right, and now part C, the limit as x approaches -1 of the function f of x. What do you think that value is going to get closer and closer to?
0.
0. Because on the left side, it's getting closer and closer to 0. On the right side, it's getting closer and closer to 0. They have to be going in the same direction or the same value. So the limit as x approaches -1 of that function would be 0. And then part D, f of -1. They just want the value of that function when x is -1. What would that be? 0. Because at -1 is on the y-axis. Yeah, on the x-axis is 0. All right, questions on number 8. All right, number 9. If it exists, we're going to find the limit as x approaches -1 of 3x plus 10. In this case, this is just a linear function. It's also a polynomial function in general. That means we can apply direct substitution. So that means here we can substitute the x with that -1. So it'd be 3 times -1 plus 10. 3 times -1, that's -3. And -3 plus 10 would give us just 7. So the limit as x approaches -1 of 3x plus 10 would just be 7. Okay. Are there any questions about problem number 9? All right, number 10 is the limit as x approaches -7 of x squared minus 8. All that's divided by 7 minus x. Now, as long as we don't get a 0 in the denominator, which we won't because 7 minus a -7 won't give us 0, we can use direct substitution. So in this case here, I'm going to replace the x with -7, so this will be -7, and that's squared, minus 8, divided by 7 minus x, which is -7. And then simplify the numerator and the denominator. -7 and you square it will be 49, and then that's 49 minus 8. And -7 minus a -7 would be maybe like 7 plus 7, which is 14. 49 minus 8 will be just 41 over 14. So the limit as x approaches -7 of x squared minus 8 divided by 7 minus x will be 41 over 14. Okay. Questions on problem number 10? Okay. All right, number 11. Here we're given that the limit as x approaches 2 of f of x is -6, and the limit as x approaches 2 of g of x is equal to 5. Here we're going to find the following limit, which is the limit as x approaches 2 of 2 times f of x plus g of x. So here we're going to be using those limit laws here. So this, we're finding the limit as x approaches 2 of 2 times f of x plus g of x. Well, we got the limit of a sum that can be written as the sum of the individual limits. So I can write this as a limit as x approaches 2 of 2 times f of x plus the limit as x approaches 2 of g of x. Now I can use one more property, and that is that what they call the constant multiple rule. That 2 right there can be pulled out in front of the limit notation. So it'll be 2 times the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. So here we got 2 times. Well, we're told that the limit as x approaches 2 of f of x is -6. So we got 2 times -6 plus the limit as x approaches 2 of g of x. Well, that's 5. Now let's simplify. 2 times -6 is -12. -12 plus 5 is -7. Okay. All right. Questions on number 11. All right, problem number 12. Here we got the function f of x is equal to -9x minus 9 divided by x minus 9, and that quantity is to the 4th power. So here we're going to find the following limits here. Okay, let me pull this up. Here we're going to find the limit as x approaches 9 from the left of f of x. And of course, I'll just write this out. The limit as x approaches 9 from the left of what f of x is. That's that x not negative 9x minus 9 divided by the quantity x minus 9 raised to the 4th power. Now, best way to do that is to put this in the graphing calculator to see what the behavior of that function is going to be. So if I do y equal to, I'm going to clear this equation out. So I have a negative, and I'm going to put the 9x minus 9 in parentheses. So negative, and then left parentheses, 9xc theta n for the x minus 9, close parentheses, divided by, and that denominator is going to be in parentheses as well. So it'll be left parentheses, xc theta for the x minus 9, close parentheses. And then press the hat key for the exponent, and then that exponent is a 4. All right, so let's see what this is going to look like here. I'm going to have to do zoom fit if I can.
What does zoom fit mean?
But what it means is it's going to take that graph and try to fit it on this
Oh,
screen.
Okay.
Yeah, if at all possible, it helps. Okay, so that's not helping me either, so let's do this. If I do table set, no, let's do the window. And I'm going to go, the x will be from 0 up to, let's say, 20 in increments of 2. So that way I can see what's going on here. Okay, that's not helping either. Because I know I did this problem before. Okay. because I don't think the standard window is going to help me any. Well, I know it's going down. If I approach 9 from the left, it's going downward to up to negative infinity. Okay, I see that.
So if we have an issue when we're doing the test, how we just gotta keep playing around?
Yeah, you're going to have to. Okay, so that's what, part A?
Yeah.
Okay, now part B is a limit as x approaches 9 from the right.
So the negative is left and the positive is right on the plus and minus thing. Like that's what.
Yeah.
Okay, that's a compliment.
Now let's see here. I'm gonna do window here. The x, I'm gonna do from -5 to 15 on the scale of 1, and let's see what happens there.
So it's still a negative.
Negative, yeah. Because it's going downward. Because to the right of 9 is going downward, so it's going to be negative infinity as well. And then part C is the limit as x approaches 9 itself of that function f of x. Well, based on that, where you think it's going to be going to?
Negative infinity.
Negative infinity, because it's doing the same thing on both the left and on the right side of 9. Okay. All right, questions on problem number 12. Okay. Now, number 13 is for the polynomial function p of x is equal to 14 plus 4x is 6 minus 7x is 7. You're going to find the following. Part A is the leading term, and then part B, the limit of p of x as x approaches infinity, and the limit of p of x as x approaches negative infinity. And here we got p of x is equal to 14 plus 4x to the 6 minus 7x to the 7th. And you know what I would do here? Write this in descending powers from the highest exponent to the lowest exponent. So that negative in front, 7x to the 7, that's negative 7x to the 7. I'll write that first. And then next will be 4x to the 6. And then the constant term will be last, which is plus 14. Now, in that problem, what would be the leading term?
7.
Is it just 7?
Would it be 6 too?
It's this right here.
7x to the 7.
Right. The term itself. Negative 7x to the 7th. Now the B part is finding the limit as x approaches infinity of p of x. And that would be the limit as x approaches infinity. And we just take the leading term, negative 7x to the 7th. If I let x approach infinity, this part right here, and another way I can write that would be like negative 7 times the limit as x approaches infinity of x to the 7th. Now this is to an odd power, so that means it's going to be going to infinity. And negative 7 times infinity, that's negative infinity. Okay. Questions about part B?
No.
Okay. All right. Now part C is the limit as x approaches negative infinity. of p of x. So we just look at the leading term. As x approaches negative infinity, we're finding the limit of negative 7x to the 7th. And I can pull the negative out in front, so it'll be negative 7 times the limit as x approaches negative infinity of x to the 7th. Now, where do you think x to the 7th will be going as we let x approach negative infinity?
Positive infinity.
Negative infinity. This time it's negative infinity. And then negative times a negative will be positive. So in this case, 7 times infinity, it's just going to go to infinity. Okay. Are there any questions about problem number 13? Okay. Okay. All right, number 14. For the function f of x is equal to 4x plus 9 divided by 7x minus 7, we're going to find each function value and limit. And then you're going to use negative infinity or positive infinity where appropriate. So here we got the f of x is equal to 4x plus 9 divided by 7x minus 7. And in part A, we want the value of that function when x is equal to 10, which is what f of 10 means. So all we do there is just substitute each x with 10 and simplify. So it'll be 4 times x, which is 10, plus 9, divided by 7 times x, which is 10, minus 7. So 4 times 10, that's going to be 40. 40 plus 9 is 49. Then the denominator, 7 times 10 is 70 minus 7.
63.
Yep, 63. And I think we can reduce 49 over 63 to what? And if this helps. 49 divided by 63. And then press the math key. Number 1 for fraction. 7/9. Okay. All right, are there any questions about part A?
No.
Okay. Part B is f of 100. So here we substitute the x with 100, so it'll be 4 times 100 plus 9 divided by 7 times 100 minus 7. You can if you want to. Yeah, you're going to get the same thing. Because you're going to have to do multiplication first and then add. 4 times 100.
400
Four.
minus 9.
Yeah, 400 plus 9.
400 plus 9. I wrote it wrong. But 409.
409. And then 7 times 100. That's 700 minus 7.
Yeah, 693.
693. I don't think you're going to be able to reduce that because you can take that in, math, and then number 1. It's still going to be 409 over 693. Okay. All right, questions on part B?
No.
Okay. Part C. This time we're finding the limit as x approaches infinity. 4x plus 9 divided by 7x minus 7. There's a couple of ways you can do this. One of them is to divide each and every term in the numerator and the denominator by the highest exponent of that denominator. But if you look at your numerator and your denominator, the highest exponent in the numerator is what? What's the highest exponent in the numerator?
1.
1. And what's the highest exponent in the denominator?
1.
1. M and N are the same. So I can look at their leading terms and get the limit for that. So it'd be the limit as x approaches infinity of just the leading terms here. 4x divided by 7x. And those x's divide outside the limit as x approaches infinity of just 4 over 7. And what's the limit of a constant? It's going to be that constant, so the limit as x approaches infinity of 4 sevenths will be
Like 4 over 7.
4 over 7. Okay. Now, in my notes here, what I did was divided every single term by x, you can see. 4x divided by x would just be x. 7x divided by x would be 7. Then I have 9 over x in the numerator and minus 7x in the denominator. And as x approaches infinity, this will go to 0. Because there's a rule that says limit as x approaches infinity of 1 over x, or 1 over x to the n, would be 0. Okay. Questions about problem number 14? Okay. Number 15 is finding the horizontal and vertical asymptotes for the function f of x is equal to 2x squared plus 3x minus 9, whole things divided by x squared plus 2x minus 15. Now let's first find the horizontal asymptote of this function, or for the graph of this function. Okay, we identify the m and the n. What would be the m in this case?
2.
2. And what's your n?
2.
2. Does m equal to n?
Yes.
Yes, it does. So here we can look at our leading terms here. So be y equal, the leading term is 2x squared in the numerator and the x squared is in the denominator. And here your x squares divide out. So you'll be left with just 2. So the equation y is equal to 2 is your horizontal asymptote. Now for the vertical asymptote, first of all, I want to make sure I have no common factors in the numerator and the denominator for f of x. Okay. Let's see here, that 2x squared plus 3x minus 9, I believe I can factor that out into two binomials here. That 2x squared breaks up as 2x and x. Minus 9, the only factors of minus 9 will have to be 3 and 3, plus 3 and a minus 3. So let's see, if I put the minus 3 here and the plus 3 here, and I'm doing this by trial and error, the outer will be 6x, the inner will be minus 3x. 6x minus 3x gives me that 3x is the middle term. So the numerator factored out would be 2x minus 3 times x plus 3. Let's factor the denominator. Got the x here and x here. Factors 15 that will give me a middle term of a 2x will have to be plus 5 and a minus 3. Plus 5x and a minus 3x will give me a plus 2x. So that'd be x plus 5 times x minus 3 in the denominator. Well, unfortunately, I don't have any common factors to divide out. So I can go ahead and find out what my vertical asymptotes are by setting the denominator of x plus 5 times x minus 3 equal to 0. And then we set each binomial factor equal to 0. So it'll be x plus 5 equals 0, and x minus 3 is equal to 0. Well, for the x plus 5 equals 0, that means x is equal to negative 5. And then for the x minus 3 equals 0, you have x is equal to 3. So these are my two vertical asymptotes here, x equal negative 5 and x is equal to 3. Now here with those vertical asymptotes, it's very important that you do factor the numerator if at all possible and your denominator if at all possible. That way you want to make sure that you have no common factors to divide out. And if that's the case, then you go ahead and divide those out and then identify your vertical asymptote. Questions on number 15. Okay. All right, number 16, that deals with continuity. So in part A, you have the graph given to you. And we're going to find the limit as x approaches negative 3 from the left of this function f of x. So negative 1, negative 2. This is negative 3 right here. If we come in from the left of negative 3, where is this graph? What value of y is this graph getting closer and closer to?
1, 2, 3. Negative 3.
Not negative 3. Because here's 0. This negative 1. This,
That.
yeah,
2.
negative 2. It's negative 2. Okay. And then from the right, the limit as x approaches negative 3 from the right.
Would it be positive 2?
It's not positive 2.
Oh, negative 2 again.
Again, negative 2. Take a look here. Here's negative 3 coming in from the right. This graph right here gets closer and closer to
the 2.
negative 2. So that's part B. Part C is the limit as x approaches negative 3 itself of f of x. Keep in mind, the left-hand limit and the right-hand limit must be approaching the same value. Is that the case here?
Yeah.
Okay. So here the limit as x approaches negative 3 of that function f of x is also
Negative 2.
negative 2. Okay, so that's part C. And part D, f of negative 3. So we're looking for the value of that function when x is equal to negative 3. Negative 3, we do have a dot right there. So what would be that corresponding y value at that point?
4.
Negative 3. Below the x.
Yeah.
Negative 1, negative 2, negative 3. All right. Now part E is this. Is the function continuous at x equal negative 3? And you have to look at your continuity rule there. Is not.
I have a question.
Yes.
On D, it says 3 on mine. Is it supposed to say negative 3?
Yeah.
Okay.
Yeah. F of negative 3. I'm sorry. I didn't change that. So it's f of negative 3.
Okay.
I'll just wipe this out and just say f of negative 3. And we're going to say here that this is not continuous. And there is a reason for that. That is because of that third rule. The limit as x approaches -3 of that function is not the same as f of -3. So that's why it is not continuous. Because there are 3 different rules for continuity. The limit must exist, f of that constant must exist, and both the limit and the value of that function are equal to each other. Questions on problem number 16? Okay. Number 17 is this: f of x is equal to 5x minus 2. And we're to determine whether each function is continuous and use interval notation. Well, that right there, that function right there is a polynomial function, or more specific, a linear function, meaning any x value that you assign to it, you will always get a value for f of x. So that function will be continuous on this interval, -infinity to infinity. It's continuous everywhere. Okay. Questions about part A? Okay. Part B, here we got a rational function g of x is equal to x minus 1 divided by 9x squared minus 64. Well, we do have a problem here because somewhere in this denominator, we're going to get a 0 here. So we need to find out what values of x that will give us a 0 in this denominator. So we'll take that 9x squared minus 64 and set that equal to 0. And what I'm going to do here is solve this equation for x. So if I add 64 to both sides, that would mean 9x squared is equal to 64. And then divide both sides by 9. You'll get x squared is equal to, and I'll still say 64 over 9. What's the opposite of squaring something?
Square root.
Square root. So I'm going to take the square root on both sides, and I'm also going to include that plus or minus symbol. So I got square root of x squared, that's x, and it's equal to plus or minus. What's the square root of 64?
8.
8. Over the square root of 9. Just be 3. So it'll be plus or minus 8/3, where we know we're going to get a 0 in the denominator. All right, now, to get the intervals where it's continuous, let's say 8/3 is 8/3 over here, and -8/3 is over on the left of 0. In this case, at 0, well, at 8/3 and -8/3, we're going to get 0 in the denominators. Any x value less than -8/3 would work. Any x values greater than between -8/3 and 8/3 would work, and any x value greater than 8/3 would as well. So this function, g of x, is continuous on the interval from -infinity to 8/3, and then from 8/3, -8/3 to 8/3, and then finally from 8/3 on to infinity. -8/3. Okay. Are there any questions about part B?
No.
Okay. Part C is the h of x equaling to the square root of x minus 2. Now here we got a radical function, and it's a square root. So we take what's underneath that square root symbol, x minus 2, and it's got to be greater than 0 because of the fact that we can't take the square root of a negative number. So it's got to be x values or something where x minus 2 is greater than or equal to 0. So to get x by itself, we add 2. That means x is greater than or equal to 2. So any x value greater than or equal to 2 will satisfy that radical function. Now, of course, you have to give the interval notation for that. Now, here, we need to use a bracket at 2 because 2 is included, greater than or equal to. And any x value greater than 2 will satisfy that function. So that means that this h of x function is continuous on the interval 2 to infinity.
That one looks good.
Hmm.
I said that one looks good, like equal.
Okay. Any questions on this?
Uh-uh.
Okay.